So in our previous part, we discussed about the Ansys optics and photonics workflow. So in this part, we want to focus on Lumerical for the nanoscale simulation. So let's because in AR glasses, in AR waveguide, we need to design 1D or 2D grating. So let's focus on the waveguide simulation for the AR. So this is one workflow that we can see here. So this is 1D grating. So in the 1D grating, we have some parameters like height, uh, period, width, filling factor, angle. So we want to optimize the geometry of grating to direct light into -1 grading order. So for normally incident light, so we will try to optimize the grating geometry. Then in the next part, we will optimize the grating at a range of angles and both direction. I mean full grating characterization with a JSON file. We can use this JSON file for the other softwares like Spills, and I will show you a demo that how we can use this grating, let's say for head-up display. So let's go to the Lumerical. So I will open the Lumerical for the 1D grating. So this is the Lumerical FTTD. We want to focus on RCWA. In the RCWA, you can see you can add the RCWA from like here, add RCWA. So this is our grating structure. Let's if I go to the modern view of Lumerical FTTD, you see we have a base, we have the first grating, second grating, third grating. Just because grating is a periodic structure, so one cell is enough for the simulation. So for the RCWA, if you click on the RCWA, you see that the direction is backward, 2D Y normal, and this is the interference reference positions, and our solver, you can see the parameters, the material, and so for this case, because we want to simulate just one incident angle, so I use a single, but also you can use a range or table. So for the second step for optimization for all of the angles, so we can use this, and this is the result. Just we want to report the index, grating order, and report fill amplitude. So let's run the simulation first. So the simulation is finished. If I select the RCWA and if I select the grating order and right click and select visualize, select new visualize, and just let's focus on TS grating, and for you see for the horizontal axis is a grating number, grating order. So for let's say for we want to optimize grating order of -1. Now it's around 0.56%. So we will try to optimize this. So in the Lumerical FTTD, it's possible. So if I go to the optimization and sweep. You see, I defined optimization before, so you can find the whole information of this example of the Ansys knowledge base article. So here is the, here is the article. So you can see that surface relief grating for augmented reality system. So we want to optimize the period, width, height. So in the next step we want to do the optimization and sweep. So if I right click on this and select edit object, you can see different parameters here. So our algorithms is actually particle swarm, and so we have like we can use 12 generation, and so the generation size is 24. About this algorithm also, please look at the knowledge base article of the Ansys. But for parameters, we want to like optimize the we want to play with the fill factor, height and slant angle. So this is the minimum and maximum value, and the result we are interested is the grating order. But the thing that in the advanced, in the figure of merit, you see that first we like get the result of grating order for the S-polarized grating as a TS, and then we want to find the number of grating. Our goal is -1, and this is our figure of merit. So the figure of merit that we defined here is the S-polarized for the grating of -1. So this is the FOM, figure of merit. So if I run the simulation, run the optimization, so let's say because I ran this one before, so the result is ready because it takes some time. So let's visualize the result. So for the result, you can see that the best FOM that we got is 0.94, so around 94%. Imagine that, like if you remember, our first result was around 56%. About the parameters, because we had 3 parameters, so if I visualize the parameters, we have like 3 parameters, but let's I can export to the clipboard. So let's say open the notepad. So if I open the notepad and paste the result, you see that the parameters is for the first parameter is 0.6, the second parameter 3.2 or 0.32 micrometer, and 32. So I mean the parameters for the grating for the optimization, this is, I mean this is the first parameter, second and third. I mean let's open the notepad again. So the best filling factor is 0.6, and the best height is 0.32, and the best angle is 32.8. So by this value we can achieve around 0.94, 94% for the first grading, so first order. Yeah, this is one example of RCWA.